Now, today's question is comes from Cambridge International, AS, and A level. The paper is paper 6, Probability and Statistics 1, S1, taken October, November 2019. The code is 9709/62. Now, the question of interest is question 5, which is a continuation of our coverage of discrete random variables, which is considered in paper 6, Probability and Statistics 1. So question 5 reads, a fair red spinner has 4 sides, numbered 1, 2, 3, 3. A fair blue spinner has 3 sides, numbered -1, 0, 2. When a spinner is spun, the score is the number on the side on which it lands. The spinners are spun at the same time. The random variable x denotes the score on the red spinner minus the score on the blue spinner. Draw up the probability distribution table for x, Roman 1. Find variance of x, Roman 2. Yeah, so there are only those ones. Now, here what the question requires us is that we have 2 of them, and then we need to consider the possible combinations of having pairs, because x is our random variable of interest, but we are told it denotes the score on the red spinner minus the score on the blue spinner. That would indicate that if we perhaps got a 2 and 2 for the red spinner and say 0 for the blue spinner, then our x is 2 minus 0, which is 2. So let's see what our solution looks like. Yeah, now the question, as we have seen, is there are 2 spinners. There is a red spinner and a blue spinner, and random variable x is defined as the difference between the red score minus blue score. Because in this experiment, the 2 spinners are considered to be fair. There's a red spinner with the 4 sides numbered 1, 2, 3, 3. And another fair blue spinner with the 3 sides numbered -1, 0, and 2. Now, we are told that when a spinner is spun, the score is the number on the side on which it lands. The spinners are spun at the same time. Now, the random variable x denotes the score on the red spinner minus the score on the blue spinner. Now, draw up the probability distribution table for x, that's for max, then find variance of x. So I think the first thing that we need to do is to figure out how many possible outcomes can we have if we were to carry out this kind of experiment. Looking at it by going, if I go by the fact that the red spinner has 4 outcomes and the blue spinner has 3 outcomes, it is possible that I'm going to have about 12 combinations. That is 3 times 12. So first, let me consider all the possibilities, because it means that they're going to be 12. So each value of the red spinner, will come 3 times, and each value will come 3 times. That it will come 3 times. Let me just draw it so that we see. So I have, if I say this is red, well, it's red week anyway. I say red. Now let me not go that way because it will be difficult to see. Let me just say red. That should mean red, and this should mean blue. So those are the ones we have. Red and blue. Red and blue. So there's a red spinner and a blue spinner. So let's see, what are the possibilities? It is possible that in a throw, I end up with 1 and -1. Okay, let me write them here so that we see. Sorry. Let me just start as R is 1, 2, 3, 3. And B is -1, 0, and 2. 0 and 2, like that. So I want to see the possible combinations. I have red and I have blue. So I just want to consider the possible combinations, the combinations that I can possibly obtain. So what if I start with 1? It is possible that I get 1 and -1, or I will get 1 and 0, or 1 and 2. In which case, 1 is going to appear how many times? 3 times. So 1 minus 0, then 1, 0, then 1, 2. 1, 2. Those are possibilities. Then I come to 2. 2, -1, 2, 0, 2, 2. 2, 2. That is 2, -1, 2, 0, 2, 2. Then I get to 3. Then I have 3. This 3, -1, 3, 0, and then 3, 1. 3, 2. Then 3, 2, 2. Then 3, 2. Now, these are the possibilities. These are the possibilities. But still, I see that I still have the possibility. I see that I still have the possibility of now there's another 3. So that 3 again will just follow the same pattern. The other 3 will just follow the same pattern. So it is 3, -1, 3, 0, and then 3, 2. 3, 2, then 3, 2, like that. So those are the possibilities that I have. Now let me see what my random variable x then looks like. X was supposed to be the difference between red and blue scores. Between red and blue scores. So 1 minus -1 is 2. 1 minus 0 is 1. 1 minus 2 is -1. 2 minus -1 is 3. 2 minus 0 is 2. 2 minus 2, 0. 3 minus 1, 4. 3 minus 0, 0. 3 minus 2, 1. 3 minus -1, 4. 3 minus 0, 3. 3 minus 2, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Those are 12 possible outcomes that we could have from that experiment. So those are the possible outcomes. And if that is so, we then realize that we need to draw probability distribution table, because that is what we are asked. But first we need to remember that there are 12 possible combinations and of outcomes, and each of them is equally likely to occur. It then means that each outcome will occur with a probability of 1 over 12. So we want to draw the probability distribution table of our random variable x, and we start by saying x and then probability that x takes that value, like that. So we see that x has taken the value 0, 1, -1, 2, like that. Those are the values it has taken. So I want to take all the values it's taken. So I want to say there is 0, -1, 1, 2, 3, 4. Yes, those are the values it's taken. So what are the probabilities? We see that how many times do we have 0? 0 occurs how many times? From our table, we find 0 how many times? Let me see. Let me just see. There is 0 here, yes. But this other 0 is what? This should be 3. So because we have 4, 3, 1, 4, this is 3. This is 3. Because it's 3 minus 0 is 3. It's 3. 3 minus 0 is 3. 3 minus 0 is 3, like that. Yeah, 3 minus 0 is 3. That's how they go. That's how they are mapped, so that there is no confusion. Yeah, that's how we have mapped them. Yeah, that's it. So we see 0 coming once, so its probability will be 1 over 12. It's only coming once, so it's only fair to give it that probability. That is 0. Then negative 1. Negative 1 also, if we check in this column, it comes once. So again, probability is 1 over 12. And 1 comes 1, 2, 3. So that's 3 over 12. And 3 over 12 is a quarter. But let's just say 3 over 12. We know it's a quarter. And then 2 comes how many times? 1 once. So it's 1 over 12. No, 2 is 1, 2. So it's 2 over 12. 2 over 12. Then 3, we see 3 how many times? 1, 2, 3. So that is 3 over 12. And how many times do we see 4? We see 4, 1, 2. So that is 2 over 12. 2 over 12. And that is the probability distribution table that we wanted. This is how we map them. That corresponds to that. This corresponds to this, like that. Like that. That's the table. So, what is the next question? The next question requires you to, having drawn the table, you are asked to get the variance of x. Now, var x, variance of x will be given by expected value of x squared minus expected value of x squared as such. So first we need to get the expected value, and we say that expected value of x is equal to 0 times 1 over 12, which is 0. So it's summation of x dot p, x is equal to x. So the first instance is 0 times 1 over 12, which is 0, plus minus 1 times 1 over 12, so that is minus 1 over 12, plus 3 over 12, plus 4 over 12, plus 9 over 12, plus 8 over 12. And that is 17, 21, 24, 23. So it's 23 over 12. It's 23 over 12. 23 over 12. That's what we get. Expected value of x is 23 over 12. So what is expected value of x squared? Expected value of x squared will be summation of x squared dot probability that x is equal to x, like that. And that means that we have 0 squared times that is just 0, plus 1 squared is just 1, that gives me 1 over 12, plus 1 squared, that gives me 3 over 12, plus 4, that's 8 over 12, uh, 9, that's 27 over 12, then 32 over 12. And this gives me, what that should give me is 1 plus 3 is 4, 12, 12 plus 32, that's 46. 46 plus 27, this is 3, 6, 73. So I have 73 over 12. 73 over 12. That is what I have as expected value of x squared. Let me see. Let me just see once again. 0, 3, 0. This is 1 over 12. This is 3 over 12. That is 4 times 2, 8 over 12. And that becomes 9 times 3 is 27 over 12. Then 16 times 2 is 32 over 12. So 32. Now, this is 4, 12 plus 32. 32 plus 12, that is 4, 44. 44 plus 27. Plus 27. That's 71. So I have here 71. This is 71, not 73. 71 over 12. Therefore, var x. Therefore, the variance of x as required is 71 over 12 minus 23 over 12 squared. And that, if you work out that using your calculators, the value that you should get is approximately 2.24. Approximately 2.24. It's approximately 2.24, but it is indeed equal to 323 over 144. And that's the answer. So if you have any question pertaining to anything that you didn't follow, please leave a comment, or you can WhatsApp me through the number that I've left there for further explanation. And also, do remember to comment with what you would want, the topic that you would want me to consider in my next video. So up to there, see you in the next video.